All right, so today we're going to tackle technology from a totally different angle. Forget the hype, forget all the buzzwords. We're going to treat this like a high-level lecture, and we're going to break down today's most influential technologies right from their first principles. Our goal isn't just to see what these things do, but how they're actually built, how they're architected, and most importantly, how that architecture creates real, tangible economic value.
And this right here, this is the core idea for everything we're talking about today. It's really the foundation for our entire discussion. We're shifting our mindset from, hey, what is this cool new tech, to what fundamental problem does this specific architecture solve for a business? That's the mindset of a true architect. And that's the lens we're going to be using throughout this entire analysis.
So here's a quick look at our syllabus for today. We're going to start by defining 3 foundational layers that really prop up most modern systems: trust, intelligence, and scale. Then, we'll see how they all connect and work together in a bigger ecosystem. And finally, we'll talk about what the true role of an architect really is in this new world. Okay, let's dive into our first foundational layer, and it's all about trust. In a world that's getting more and more decentralized, the biggest challenge is creating systems that we can actually rely on. Blockchain is the answer here, not as a currency, but as a completely new kind of trust infrastructure.
So what's the fundamental problem that blockchain actually solves? Well, it answers a really old, really difficult question. How can a group of different people or companies, who maybe don't even trust each other, all agree on a single, shared source of truth without a central middleman calling the shots? It basically lets you replace trust in a big institution, like a bank, with trust in a protocol, trust in the math and the code itself.
So how does it pull this off architecturally? Well, it's these key pieces working together. You start with a network of peers, computers talking directly to each other. Then you need a consensus mechanism, so they can all agree on what's true. And once they agree, that truth gets locked into this immutable ledger where it can never be changed. The real magic isn't any one of these parts. It's how they combine to create what we call deterministic distributed agreement. That's the secret sauce.
But, and this is a huge but, this powerful architecture is not a silver bullet. It's not a solution for everything. And this slide really highlights those critical trade-offs. Blockchain is absolutely perfect for something like tracing a product across a supply chain with dozens of different companies. But it would be an absolutely terrible, clunky, and inefficient choice for a high-speed trading system or just your company's own internal database. The architect's real job is knowing that difference.
So what's the payoff? Well, this architectural strength leads directly to economic value. When you build in trust at the lowest level, you start to slash costs from things like fraud and reconciliation. You can cut out expensive middlemen, and you can build entirely new digital economies. Trust itself becomes a programmable economic asset.
Okay, so building on that foundation of trust, we can now move to our next layer. Once we have a system where the information is verifiable and trustworthy, we can start adding a layer of intelligence. And that, of course, is where artificial intelligence comes into the picture. So what's AI's big job here? At its core, it's all about recognizing patterns and making predictions on a massive scale. See, unlike traditional software that just follows a rigid set of rules you program into it, AI systems can actually learn from data. They can spot anomalies, forecast what's coming next, and make decisions that adapt over time. It moves a system from being purely deterministic to probabilistic, meaning it can make really, really good educated guesses based on what it sees.
Now, don't just think of AI as a single algorithm. Behind the scenes, a real AI system is a complex piece of infrastructure. It's a whole ecosystem. You've got these data pipelines, constantly feeding it information, layers that process that data, environments where the models are trained, and, critically, these feedback loops that let the system keep learning and getting smarter over time.
And where do we see this in the real world? Well, it's pretty much everywhere. Think about it. Spotting a weird credit card charge in milliseconds, predicting that a jet engine needs maintenance before it actually fails, or forecasting how much product a global retailer needs to stock. These are all incredibly complex problems where AI's ability to predict provides enormous value.
The impact on business is just massive, and you can really measure it. As you can see here, AI creates value all across the board. It makes operations way more efficient, which saves money. It makes things like risk assessments far more accurate, and it automates complex decisions, which frees up your people to do more valuable work. It hits both the cost and the revenue side of the equation.
All right, so we've got trust, we've got intelligence. But what's the point if you can't deliver these things to millions or even billions of users reliably? How do you make it scale?
And that brings us to our third crucial layer, the scale layer, which is all about cloud-native architecture.
So the core problem that cloud-native architecture is built to solve is all about scalability, resilience, and speed. It lets a system react to demand dynamically. It can grow instantly when traffic spikes on Black Friday and then shrink right back down on a quiet Tuesday morning, all without a human having to flip a switch.
Now, the big idea here, the key architectural principle, is decomposition. Instead of building one giant, clunky application, you break it down into dozens, maybe even thousands, of tiny, independent components called microservices. Each one gets packaged up neatly in a container and managed by an orchestrator. This is what lets you scale just one tiny part of the system that's under heavy load, which is incredibly efficient.
And this elasticity, this ability to grow and shrink on demand, that's a massive economic engine. It makes you way more efficient because you only pay for the resources you're actually using. It lets you get new products out the door so much faster. And it boosts revenue because a system that's always available means happier customers. Your ability to scale is directly tied to your ability to make money.
Okay, now for the really cool part. These three layers, trust, intelligence, and scale, they don't just sit there by themselves in isolation. The real magic, the real power, happens when you start weaving them all together into one complete, responsive ecosystem.
Think of event-driven architecture as the central nervous system for your entire system. It allows all those little microservices to communicate without being tightly coupled together. They just react to events, like a new order coming in or a sensor taking a reading. This is what makes a system feel like it's responding in real time and makes it way more resilient.
And if event-driven architecture is the nervous system, then the Internet of Things, or IoT, gives the system its eyes and ears. It's the bridge between the physical and digital worlds. It connects devices, sensors in a factory, your smart thermostat at home, a connected car, to the cloud. This provides that constant stream of real-world data that our AI intelligence layer needs to thrive.
In AR and VR, this is becoming the new user interface, the new way we interact with all this complex data. Instead of looking at a spreadsheet, imagine an engineer who can see a jet engine's real-time sensor data literally overlaid on top of the engine itself. It lets us visualize and engage with information in these completely new and much more intuitive ways. Finally, and let's be crystal clear about this, cybersecurity is not some feature you bolt on at the end. It is absolutely foundational. It's the layer that protects all of the immense value being created by the rest of the system. You have to stop thinking of it as a cost center and start thinking of it as a revenue protection layer.
So this brings us to our final and maybe our most important section. After looking at all these incredible technologies, what's the ultimate takeaway here? Well, it all comes back to the role of the person who has to understand and combine all of these pieces, the architect.
After all of this, here's what it really boils down to. Architecture is the bridge. It's the discipline of translating these amazing technical capabilities like distributed trust or predictive intelligence into real, measurable, and sustainable economic value for a business. That is the architect's ultimate job.
And this leaves us with one last question, a question for you to take back to your own work. Ask yourself this: are you simply implementing the latest technology just because it's new and exciting, or are you thoughtfully architecting solutions that create tangible, lasting value? The difference is everything.